All right, folks, we'll get going here in just a few seconds. Um, Curious, and since I'm so sad that I can't be there with you folks in person, how was the breakfast this morning? I can't hear you, so raise your hand if you had a good breakfast this morning. Awesome. Oh my goodness, so many morning people eating breakfast. So it's actually 1:30 a.m. my time. Let's see, I guess it's still Thursday. It's kind of my Wednesday. Unfortunately, my family had a COVID outbreak within our household, so I couldn't come out there this week. I'm really sad to not see you in person. I appreciate you accommodating me in this remote forum. Um, but I'm glad you're there. I hope you folks are having a good time. Raise your hand if Øredev 2022 has been as awesome as you had hoped. See lots of hands. Awesome. Cool. So let's go going. My name is Jeff Handley, and I'm from the .NET Libraries team at Microsoft. I'm going to talk to you today about .NET 7. Raise your hand if you've heard of .NET 7 getting released this week. Was announced at .NET Conf 2022 earlier this week. Thank you for that participation. It really helps me feel the room a little bit. There's so much in .NET 7 that there's no way I can cover it in 40 minutes. So I'm focusing on just what's coming out of the .NET Libraries team, some of the key updates from our team. If you want to learn more about .NET 7, the wide array of new features and updates in it, check out all the content from .NET Conf 2022. There's so much content out there. It's all free. It was all virtual, remote, streamed. So check it out when you can. Diving in, I want to start with branding and versioning because I know it can be kind of confusing. We had .NET Framework and then .NET Core, and now we have .NET. So I'm going to cover that a little bit to clear up what is .NET 7. Then I'm going to introduce the .NET Libraries team, kind of who we are, which parts of .NET we're responsible for. And then I'm going to dive in and show a lot of demos. I'm going to go as fast as I can through some demos to show some of the features in the runtime libraries that I'm most excited about, that I think you're going to find a lot of value in as well. And then we're going to wrap up talking about .NET 8. I mean, we're just releasing .NET 7 this week, and I'm going to talk about where we are in terms of our planning for .NET 8 and how you can get involved. So back to our versioning and branding. Here's the deal. We have .NET Framework. .NET Framework shipped as part of Windows. It started back in 2002, and for about 15 years, .NET Framework was Windows only. We had a lot of very specific code tied to that platform, and Windows itself has dependencies on .NET Framework. It still does. But in 2016, we released what we call .NET Core 1.0. That was the beginning of an endeavor to do a cross-platform open source port of .NET Framework into a brand new code base. This is under the .NET/runtime repo on GitHub. It's been open source since day one. And since 2016, we've been continuing to build on that code base. In 2019, we released .NET Core 3.1. And that's when we realized we were to the point where we had ported the features that we wanted from .NET Framework over into .NET Core. And the next version in 2020 was .NET 5. And that's when we dropped Framework, we dropped Core off of the name, and now our name is simply .NET. So .NET 5 shipped in 2020. Last year we shipped .NET 6. This year, this week, we shipped .NET 7. The versioning strategy we have going forward, the release schedule, is every year around this week, we release the next major version of .NET, and even numbered version numbers are long-term support for 3 years. This year's .NET 7 will have 18 months of support starting right now. So hopefully this helps paint the picture of what .NET 7 is. And I want to introduce you to our team. This is the .NET Libraries team that added these features that I'm going to show you today. We work across US and Europe. We've got folks that come from, I think, about 16 different countries that are part of the team. We own the lowest level of managed code that everything else in .NET runs on. Even in our own docs, we get our naming a little mixed up. We call ourselves the runtime libraries or the framework libraries or the core libraries, system libraries. I think what most folks refer to our work as is the base class library, so the BCL. That term goes all the way back to the very beginning of .NET Framework. That's what most folks still refer to our work as. Ultimately, we own the system namespace, and everything that ships is part of the .NET SDK or even just part of the .NET runtime in the system namespace. The way we ship this is, I know you can't read that, you're not supposed to, about 60 different libraries that we produce out of our team. Some of these are in active development, some of them are pretty much done, but we've got about 60 libraries that we ship as NuGet packages individually, and also, as I said, part of the .NET SDK and the .NET runtime itself. So I'm going to be focusing on those system namespaces today. Things like ASP.NET Core, Entity Framework, MAUI, all those folks build on top of our work, and you use our stuff too. So I'm going to give some demos and show some examples of updates across just a very small sampling of the work that we've done over this past year that, again, I'm kind of most excited about myself. Starting with System Console. I don't know if it gets more fundamental than an API like system.console.readKey. Just one simple method that you would expect works all the time, forever and always, and you should be able to rely on it. Any console application you're building that you're going to need to read a key from the command line, you expect that to be accurate and trustworthy. Well, it turns out when we ported our code from Windows over into this cross-platform world, we discounted how hard console read key is on Unix. There are so many different terminals with so many different terminal settings, so many ways to configure them. We got it wrong. And the developer working on this feature said that basically every bug we'd ever had, the way it was fixed was somebody went in and added an if statement, and we had plenty of them. So we decided to rethink it from the ground up, and we had a complete re-implementation of read key for Unix. We did this in a highly tested manner. And in .NET 7, you can now rely on System Console read key to understand your terminal settings, and particularly complex character sequences can now be read in reliably. This was something really important to PowerShell. PowerShell 7.3 also shipped this week using .NET 7. So PowerShell on Unix-based platforms is much more reliable on the command line. Next is System I/O. A couple of exciting new APIs here, all the way down to System I/O Stream. We introduced read at least and read exactly, plus the async methods of those. Something we learned just within the last couple of years is that System I/O Stream has a method called read. You pass in to read the buffer that you want bytes read into. You give it the offset to start the read and a count of how many bytes you would very much request that we read into your buffer. But what we learned is that very few people were paying attention to the int that is returned from stream.read. What that int return value tells you is how many bytes we actually successfully read into your buffer, because we'll read up to what you requested, but we can't always guarantee from stream.read that we'll read the number you requested. There might not be that many bytes, or the operating system underneath of us might stop at a lower level and give us a subset. So we introduced read at least and read exactly that will do exactly what those two things say. We also implemented some fixes on symbolic links. In .NET 6, we introduced new APIs for symbolic links that work in a cross-platform way. We got a lot of usage of those, particularly cross-platform usage on distributions of Linux that we hadn't really used ourselves deeply in this level. Based on that feedback, we fixed some bugs both in .NET 7, and a lot of those we backported to .NET 6 and our monthly servicing updates. So some exciting stuff there. All right, let's jump in and do our first demo. I'm just going to use Sublime here. I'm going to CD into a new directory, and I'm going to call this a rename dir demo. I'm going to do a new console app. We'll just launch this in Sublime. Now, our template, of course, is using top-level statements. What I want to show you is a small bug fix that we made to system IO directory info that, albeit small, I think is actually really valuable. So we're going to create a new system.io, new system.io.directory info. And we're going to create a folder called foo. And then we're going to try to move that folder to foo lowercase. Now I'm going to flip over. I'm going to downgrade this project to .NET 6 before I try running it. We're going to run this and see what happens. It created foo, but then when we tried to move it, we threw an exception. So this is one of the APIs that when we were doing our port from the Windows.NET Framework codebase over to be cross-platform, we missed this. We didn't account for case insensitivity or case sensitivity correctly here, but we fixed that in .NET 7. Now, if we run that and we look at our directory, we can see that the directory was indeed renamed to lowercase foo. So simple enough, but really helpful if you're building applications that run cross-platform and you need the behavior to be consistent between Windows and Unix operating systems. So the next demo I want to show is related to system I/O compression. In .NET 7, we introduced the ability to read TARs and tar.gz files. Now, if you've been doing anything on Unix platforms forever, you've probably encountered a tar or a tar.gz file. .NET, growing up out of Windows, didn't really have that concept as much. We had zip archives is much more common there. Let's create another demo folder here for tar. Another console application. And again, I'm just going to use Sublime Text for this one. And I'm going to copy a file from my parent folder up in here. This is actually the .NET SDK 7.0 for Linux x64. That is a tar.gz. It's how we publish and release .NET 7 for Unix platforms. What we're going to do in this application, I'm going to copy paste our code in here, but I'm going to walk through it. We're going to create a new file stream by opening a file for read. We'll just open up that tar.gz file as a file stream. And then we're going to use that file stream to create a gzip stream over that stream, and we're going to decompress it. Then we're going to create an extracted folder to have that prepped and ready. And now we're going to call our new API, tarfile.extract to directory async. So in just a couple of steps, we can decompress the gzip part, then we can extract the tar archive, and we should be able to dump all of the contents, all of the contents of that tar.gz into a new extracted folder. Let's give this a go. It'll only take a couple of seconds here. It's pretty quick. We made sure this was as performant as possible, and we can cd into our extracted folder, and boom, there's the full contents of the tar.gz file, decompressed and extracted. Of course, our tar file APIs also allow you to create, read, update, append tar.gz files or tar files directly. Really hope this will help you out on these cross-platform apps that you're building. All right, next thing I want to talk about is the system.net library. Now, I mentioned before that products like ASP.NET Core build on top of what our team produces. Well, the system.net library is one of the libraries that our team builds, but we build this in very close collaboration with the ASP.NET team. Some of the features that are coming out here in .NET 7 are support for HTTP3 and Quick. HTTP3 is something that we expect will be the default in .NET 8, but for .NET 7, we've made it opt-in. And the example code that I'm showing here is building up a Kestrel web app that can support HTTP1, HTTP2, and HTTP3. And what the code is showing is that on port 5000, we can listen to just HTTP 1 and 2 and only support those protocols on that port. But for port 5001, we'll support HTTP 1 and 2 and 3. So regardless of which of those that the client is using, that connection will be supported there. And then we can also have port 5002 listening only to HTTP3, so that the code base underneath this listener could be highly optimized for the new features in HTTP3 and based on performance and reliability there. So this stuff lights up through ASP.NET. And again, you can see more info about this in the .NET Conf sessions if you dig into the ASP.NET Core sessions there. Quick is also something we've been keeping up with. We've been following along with that spec as closely as we can. We do have Quick APIs available in .NET 7. We've got them hidden under a preview feature flag though. If you want to use the Quick APIs in your programs, you need to opt into that by using the enable preview features project or MS build property in your project file. All right, next I'm going to talk about XML. XML goes back to the very, very beginning of .NET Framework as well. This was an area across our libraries that our team didn't actually plan to do much in for .NET 7. When we published our work plan for .NET 7, we stated we weren't planning on making any notable investments there. But we did mark a bunch of issues as help wanted. And we asked the community, we invited pull requests from the community, and I wanted to give a shout out to a handful of members of the community that contributed and got merged 17 PRs into System XML. So even though our team wasn't doing anything in that space, we still had some bug fixes, some test fixes, and improved the overall quality of XML. Most notably was fixes to the recent nullable annotations that we did in .NET 5 and .NET 6. Some bugs were found in our annotations, and these community members helped fix those. So thank you to those community members and shout out to them. Next is System Text JSON. Raise your hands if you've used System Text JSON. Keep your hands up if you've been frustrated by System Text JSON. Yeah, I thought so. So hopefully you'll check out this blog post. Eric Sarpalis, Christoph Wieher, and Leonie have been focusing on System Text JSON for multiple years. These three gentlemen have worked really hard in .NET 7 to address a lot of the frustrations you've had. And we recently put out this blog post of what's new in System Text JSON and .NET 7. It's really detailed. I'm going to show you some demos of just a sampling of what they put in there. But first, I'm going to talk about a feature that we call contract customization. I'm going to show a demo of it here in a moment, but I want to talk a little bit about how we approach features in System Text JSON. So over the years, since we introduced System Text JSON in .NET Core 3.1, we've heard requests for things like, oh, let me recognize my own attributes, or let me serialize private fields, or why can't I use code instead of having to use attributes in the first place? We get lots of these seemingly small or medium-sized feature requests. And if we addressed each of them individually, we'd end up with API soup through System Text JSON. And we're really trying to be deliberate and think about classes and categories of feature requests. And what we've done in .NET 7 is we introduced something that we call contract customization. And all of those problems that you see on the screen here can be addressed with one set of features in contract customization. And I think this is going to make your lives a whole lot better. So I'm going to give a little demo here. I'm going to go back up a couple of folders and we'll CD into a new folder called contracts, and we'll do a .NET console. And I'm going to use program main here. Some of you might have noted, I think it was in .NET 5 or maybe .NET 6. We introduced the top level statements in our project template for console apps. We got a lot of feedback. Hey, give me back my program main. Well, it's there. You can now just say -- use program main. It's available in the Visual Studio dialog as well. We actually serviced that back into the .NET 6 SDK a handful of months ago. All right, so for contract customization, what I want to show is just some really straightforward serialization, deserialization to the console, and then we're going to customize the heck out of it. So let's start off by just grabbing var data equals a new anonymous type, value equals 42. And we're going to grab some JSON from that. JSON serialize our data, and we'll console.writeLine, that JSON. And then, yeah, let's take a look at what that does for us. Oh, I forgot my favorite API console read key. We put so much effort into it. Now I make myself use it on every console app. All right, so we see value 42. Let's pretend we want to customize the serialization of our object to prefix every property name with the word demo. What we can now do is, if let's see, I saw a lot of hands go up when I asked about system text JSON. I'm going to guess most of you have used JSON serializer options. New JSON serializer options. You've probably done this. There's a new API in here though of of type info resolver. This is a new property on JSON serializer options. And I'm going to create a new property prefixer. We'll let Visual Studio produce that for me. And we'll flip over to our property prefixer. This is going to be of type I, JSON type info resolver. I'm actually going to have mine derive from the default JSON info type resolver. So you can use all of the built-in JSON info type resolver functionality. And I'll explain that here in just a moment. And we can now override it. I'm going to override when the serializer or deserializer needs to have information about how to serialize or deserialize a type. We now get a hook. And I'm going to grab the base type info that the default implementation built in the box with system text JSON gives me, and I'm going to modify it. So I'm going to check to see if the info kind is an object. So if we're serializing an object as opposed to a particular value of a property or a dictionary, I can now say for each var property in info.properties, so property.name equals demo, let's make it all caps so you can see it nice and big, plus property.name. And then we'll return this info from our JSON type info resolver. We're going to flip back over here. We've got our options is getting constructed with this property prefixer as the type info resolver. Let's pass that in here to our serialize and see what happens. Boom. We just customized every property name using code. You no longer need to try to do all kinds of crazy resolver attributes and crazy system text JSON attributes on your model. You can now use code to modify the serialization and deserialization. But even this can feel a little heavy-handed. You've got full control here of all JSON type info resolvers, but there's actually even a simpler way that we can do this. So if you need to just sprinkle a little bit of modification in, we can use a default JSON type info resolver, and it has a modifiers collection. And this modifiers collection can take just static voids. So let's do a demo prefix where we get a JSON type info, and now we can just mutate this JSON type info instance. So I'm going to again be defensive. If info.kind equals info_kind object, info.var for each property in info.properties, property.name equals demo_property.name. Now we don't even need to return this info because we're just mutating the one we have here. And modifiers is a collection starting with demo prefix. And I did something, oh, I know what I did wrong here. So options needs to actually be a new JSON serializer options, and it's type info resolver equals. Did that a little bit wrong there. All right, let's see if we can get this fixed. There we go. All right, so we have a JSON serializer options where the type info resolver is the default with modifiers set up with our demo prefix modifier in place. So if we run this, we should get the same result. Excellent. But what I love about this is that this is now composable. We can do another static method here of lowercase. We can do a JSON type info. We'll do the same defensive code, info.kind equals object. And we'll do the same thing for each property and info properties. We'll say property.name equals property.name.toLower. We'll come up here, we'll add this in of to lowercase. Now it's going to run these in the order that I specified. So first we're going to prefix with demo, and then we're going to come back in lowercase. So pause for a second. I'm curious if this is attractive to you folks, being able to just write this kind of code, sprinkle these modifiers in. I know I'm super excited about this one. All right, let's see. There's a couple other things we could do. I'm gonna a little bit of code here though to save a little bit of time. Now this is something I'm going to tell you we're not going to do by default. We're not going to give an easy feature for adding private fields because there's way too much of a security concern of exposing private fields. Now I'm going to show why. Let's see. I'm going to grab a model here real quick as well. Let's do a new item model.cs contracts. All right, let's define something where we've got a first name, a last name, private int of ID of 42. And then I'm also going to do this tax ID, and we're going to annotate that with a custom attribute for private info. And then instead of just our anonymous type here, we say var data equals, yeah, copy paste this a little bit here. New model of Jeff Handley with an all asterisks ID. Now, if we serialize that data, I'm going to replace our modifiers and I'm going to say add private fields. If we look at that implementation, when we're getting the info or when we have the info for our properties, we can go get the type of our info. We can go get the private fields and we can add JSON property infos for those private fields, and we'll prefix them with an underscore. We're going to add those into our serialized model. Going to run that. Cool. We see first name Jeff, last name Handley. We see our tax ID. We'll try to hide that in a second. Here's part of where private fields get tricky. So if you're going to write something like this for your contract customization, bear in mind you're going to have all the backing fields for your properties. You're going to need to deal with that. But we do have our ID 42 in here. So if you need private fields in some specific contexts, you can now write that code and use contract customization to get that brought in. All right, one last feature I'm going to show here, then we're going to bounce out of this demo. I showed that tax info, and it is a private info field. Again, using a custom attribute. We can now exclude private info. We'll use a modifier for that. And what this is going to do is look at the properties being serialized as part of this info. And if the private info attribute is defined, we're just going to null out the getter and setter for these. So we can run that and boom, tax ID is now hidden. So all these features in system text JSON serialization that you've wanted to be able to pull off, but you couldn't because we didn't give you attributes or other hooks to be able to do it. Now you can drop down to custom contract or contract customization, and you can write code to your heart's content to customize serialization, deserialization, however you want. So raise your hand if this looks attractive. Awesome. Thank you so much. Next, gonna keep moving fast here. I got a bunch more demos I still want to show. But first, I have to share this quote. This was on Reddit a while back. What the blank were they thinking? Somebody was asking about system text JSON. And they went on about a 4-page rant of features that they thought were missing. A lot of them I just showed are now possible. Another one, another comment was, the latest ridiculousness I've just found is the stupidity of not being able to use polymorphism. We understand the frustration there, but we've got some good news. In .NET 7, actually an effort that started in .NET 6, we wrote a user story stating that developers can use system text JSON to serialize type hierarchies securely. Securely is the key word here. Polymorphism and serialization and deserialization is dangerous. Please hear me. Deserialization, polymorphic type hierarchies is dangerous. You can accidentally allow input to come in that can deserialize objects that you don't want to get deserialized. We do not take this lightly. We built binary formatter in .NET Framework. We have obsoleted it. It will be the first feature that gets removed from .NET. In .NET 9, I think it is, we're literally removing the binary formatter APIs. We take these problems of security very seriously. We wanted to make sure if we built polymorphism into system text JSON, you would be able to trust it for its security and performance. So we spent a lot of time designing it. We looked at a lot of the scenarios that folks wanted to use it for, and we made sure that we could do it right. So let's take a look at what polymorphism looks like. I'm going to copy paste some code in here and delete. I'm going to delete our model and delete our property prefixer. We don't need those anymore. So there's a couple different ways to do polymorphism. First is with the contract customization I just showed. That's probably my preferred way to do it. We can actually now use a modifier that is a JSON type info, or takes that info and mutates it. And we can check to see if we're in this hierarchy of base class and derived class. And what we need to tell the serializer and the deserializer is if you see something that is base or derives from it, that we will understand base classes and will understand derived classes from base. And this is essentially an allow list of which types will you allow to be safely deserialized where we're deserializing a base. We're going to customize the type discriminator that will get emitted into the JSON payload. We're going to call it underbar type, and we're going to specify which derived types are allowed. So we'll say derived, and I actually need to also include base here. New JSON derived type of base with name of base. Now you can fully customize these. You don't have to use those names, but makes it pretty straightforward. All right, so in this demo, we're setting up polymorphism for base and derived. We're going to construct a base with 1, 2 as a derived type. We're going to serialize, and we're going to turn right back around and deserialize it. Let's give this a run and see how it looks on the console. So you can see the payload. We've got this underbar type that we defined. You don't have to. There is a default of $type. And we had the payload of derived being the discriminator. And we had both our Y and X properties. When we deserialize it again, we can see that it is a derived instance. Now, if you actually are using the system text JSON attributes within your models, you can skip the whole JSON serializer options and contract customization, and you can also just decorate base with which derived types can be deserialized, and you get the same result now with our default $type discriminator. So thank you folks for your patience with polymorphism. We wanted to make sure we got it right. We wanted to make sure it's safe, make sure it's something you can rely on for here forward. It is here in .NET 7. All right, whew, that was a lot in system text JSON. Raise your hand if you were previously frustrated with system text JSON and you're going to give it another look. A few of you. All right, thank you for that. We know there's still a lot more to do. Honestly, with contract customization, we've unblocked ourselves to be able to add a bunch more features in a pretty surgical manner. So keep a lookout, take a look at our work plan for .NET 8 on that as well. All right, gonna continue to move fast here. System reflection. We had a small bug fix here that we've been wanting to do for like 20 years. If you called get properties on a type, it was unpredictable what order those properties would come out in. And it turns out what was happening is anytime somebody, any piece of code, anywhere in framework or your application, if you called get property on a specific property before iterating over get properties, then whichever ones you would eagerly ask for would be at the top of the list. In .NET 7, we made changes all the way down into the native runtime and the native parts of the .NET runtime to pull this off so that whenever you call get properties, you'll get the properties back in declaration order. So sorry that took 20 years, but it's finally there. Also in System Reflection .NET 7, we added support for recognizing generic attributes, which is a new language feature, and also have better support for using reflection over open generic types. We had some frustration around that. System reflection is an area we're going to continue to invest in more as the language itself is evolving. We need to start getting reflection to keep up. So year over year, that's something we're planning to invest in more. All right, just a few minutes left. I have 2 more demos I'm going to try to show. They're both related to regular expressions. This is another space. Sometimes you think, well, regular expressions, aren't they done? What else is there to do there, right? But let's create one for a command line regular expression. .NET new console. I'm going to show a really simple console application. Oh, cancel, I did it again. Close that, don't save. Forgot to double click in program before I paste it. All right, there we go. By the way, our top level statements console app template, one of the biggest frustrations folks have with that is that how do you get to your command line args? We didn't document this very well, but args is actually just there in scope because all the code we have here is implicitly inside your program main. So args is here in scope. You can get to it. This command line app is going to read a pattern and text from the command line and just print out whether or not it's a match. So if we do a .NET run foo and food, we're going to see, yes, that's a match. Something interesting about regular expression engines going decades back is that most of them are built using a backtracking engine where you can essentially have loops in your regular expression based on how you construct them. I'm going to show what happens if we use that in a dangerous way. Let's say instead of looking for foo, let's look for the character O repeated inside a capture that's repeated, where that's the only thing that exists in the pattern. And I'm going to feed in a whole bunch of O's. Well, this works. We're going to see, yes, that matches. But if I add a bunch more O's and then a D at the end and run that, I'm going to get false. And I did something wrong here. Well, I know why, because I've already included my updated code here. Pretend that wasn't there. I'm going to run that. This particular pattern introduces a loop in how the pattern is going to be executed. And this particular string exploits that loop. And we have exponential execution time based on the length of the input string. If you are executing regular expressions with untrusted patterns or untrusted input over a pattern that uses loops like this, you are vulnerable to a denial of service attack. You should not be using a backtracking engine. Instead, .NET 7 gives you a non-backtracking engine that you can now opt into. This is something that Microsoft Research spent years researching and implementing, and they actually contributed into .NET 7, produced that code for us, and we worked with them to get the non-backtracking engine in. And now you can see this runs in guaranteed, mathematically proven, guaranteed linear time. instead of potentially exponential time. So again, if you have untrusted input as your pattern and or untrusted input for your text where you have potential exploits in your pattern, consider using the non-backtracking engine. It could save your butt. All right, I know we're just about out of time here. I'm going to do one other quick demo. We're going to cd into a new directory for a regex source gen. New console, and we're going to use program main. And I'm going to load this one up in Visual Studio. All I'm going to show is a little bit of tooling and a new source generator. Raise your hand real quick if you've seen source generators or heard of them. A few folks. All right, I'm going to show what these can do for you. We're going to create a new regular expression of just simply .NET. Now, I've got a bug here. This dot should be escaped. But since this is a hard-coded regular expression, we now get a compiler analyzer message that we could use the generated regex attribute to code gen, source gen, during design time, an implementation of our regular expression. And when I hover over it, I actually get a pattern explanation telling me what it's going to do. And if we look here, we actually have the full implementation of this particular regular expression engine optimized and reduced down to only the pieces of code that this pattern needs in order to execute. That means at runtime, your application does not even need to pull in system.text.regular expressions at all. All the code is here, and you don't have to worry about pre-compiling it. It's ready to go. And what's awesome about this is if I edit this and flip back over, we'll see that it's actually modified this code live right here. You don't need Visual Studio. This works from command line builds too. This is how we get the text that tells us what's happening, because when we generate the code, we include comments. Super fun about source generators is that you can even set breakpoints in your generated regular expression and step into the code and step through. So if your regular expression isn't behaving the way you want, just debug it. All right, performance improvements in .NET 7. I mentioned we try to be really fast. .NET 7 is faster than .NET 6, which was faster than .NET 5. I'm not going to talk much about what we did. I'm just going to show this blog post that Stephen Tobe wrote where he went into detail with all the performance work we did against the libraries. That was me holding down the page down key. It's about 135 pages worth of work we did to make .NET 7 faster than .NET 6 and faster than .NET 5. So it is really, really fast. All right, so that's it. That's what I have for today to show you about .NET 7. Parting words here is I'm going to talk about what's planned. Like I said, we're already planning .NET 8 because we've shipped .NET 7. So I have a call to action. I want you to upgrade to .NET 7. It's as easy as going into your CS project file and changing target framework .NET 6 to .NET 7. Done. Everything's backwards compatible. You can see our breaking change notes for the few breaking changes we did have, but it's pretty minimal. Next, check out our .NET Runtime repo. Something we just started doing a couple of months ago is for every single library the libraries team works on, we've been producing READMEs where we talk about the contribution bar. I mentioned XML as a place we didn't invest in heavily in .NET 7. We're not going to in .NET 8 either, but we're starting to advertise more blatantly in our repo which libraries we're investing in, which libraries we're not, which ones we want help with. So go read those READMEs to learn more about that. Submit bugs and features for things that would be valuable for you. Read through issues that we have labeled as an epic and comment on those. Give them reactions. If it's valuable to you, if you think there's something missing that you wish we would add, please engage there. And last, if you do see some issues labeled as help wanted that you want to contribute features or fixes for, comment on the issue and say, hey, I'd like to work on that. As you saw with XML and hundreds of other features and fixes across .NET 7, so many of them came from other community contributors. Last, Even though .NET 7 just came out this week, you can go get .NET 8 builds right away. You can go to the .NET installer repo and you can get builds across whatever platform you're working on. And you can keep up with us daily or with our monthly previews for .NET 8. All right, that was it. Thank you so much. I know that was fast and furious through the demos. I'm putting them all out on GitHub. I just need to update the repo. It's already out there now, but github.com/JeffHandley, Øredev 2022. Everything you saw here today is up there. I'll get the slides posted as well. Thank you so much.